Hear me?
Yeah.
No.
All right then. Good morning, everybody. Today is Friday, May 10th, and we are now launching webinar number 62, and Pete's Uncle Pete's corner session number 9, and he's going to talk about the end. Following that, quickly, will be Glenn Rathke imposing the possibilities on us. How's that?
Okay.
I'm just so happy.
I
Happy
hate to be
man.
imposed upon.
I suppose I'm imposed.
How about I meant expose.
What
I don't want
that?
No, we're going to hold the line there on exposure.
No webcams today.
Oh, too bad. Okay, so Pete, show us your quick deal on the end, huh?
All right. Well, before anyone gets too excited, I wasn't talking about the end of Uncle Pete. Uncle Pete's still going to be around. So.
Oh man.
Stop the parties. That's not the end we're talking about.
No celebration?
Yeah, we're going to talk about cleaning up after yourself. Something my wife says that I do really well. Wink, wink, nod, nod.
Right.
Yeah. So we all have procedures and functions that we run, and we've kind of all developed our different ways of cleaning up after them. Making sure that our file pointers are back to the right spot, making sure that the files get closed if we're reading ASCII files or whatever. And a lot of times it winds up being a pain in the butt because your error processing code hits an error. You want to just jump out of the procedure, but you can't because you got to make sure to get down to the bottom of your procedure to hit your cleanup code. Well, that's where the end with the little colon behind it statement comes in handy. And we're going to go through a couple of quick examples of these. This isn't necessarily functional intelligent code, but just something to get your juices flowing of what you might could use the end statement for. So this is our product form, and say we have some kind of function that goes out and reads another product record, maybe to check for similarities, compare inventory between the two different products, whatever. Well, if we put a procedure in here, I called it count similar, although when we get to the code, you'll find out that it's not counting anything. If we, let me take this code out and run this. Okay, we see here that we were on product ID 16. That's this product. Then when we got into our function, it read product 5. And then after our function got over, we're still on product 5. So we're in big trouble right now if we click the save button. We're going to save over product 5. We're no longer stuck on product 16. That's a problem. Well, we could go over to our code and do some stuff in here to make sure that we're go back and reset that code. But again, as our code gets longer and we get some error exceptions in it, it gets harder and harder to make sure that we always get down into that cleanup code. Well, we can use this end colon and as you see, we have a return statement right here. So that means that nothing's going to run I put a info statement right here, it'll never run. All right, we see we never got our info statement, again, because the return fired off before it did. But you see that we did fire that restoring position code, and now our file pointer is back to 11 where it started. So let's go look at the code, because along with the end, I'm also showing you a couple other neat little features that you may not be aware of HyperFile. Save position and restore position. So when we come in here, first thing we do is save the position of the product file. That returns an integer, and all it's doing is holding a pointer to the record that we need to be on. Now we're doing a HRead seek, which that's going to mess up our buffer. And again, our code would normally, we could easily have a couple hundred lines of code in here doing half a dozen things, reading the file 2 or 3 different times, doing some error checking, whatever. And if anywhere in that code we jump out without issuing an HRestore position, we're going to be in trouble when we get back over to the other side. So by putting that HRestore position after this end block, that end block says, no matter what you do in this procedure, on your way out, run this code. And what that's doing is doing an HRestore position, and the parameter is that integer that was returned from our save position. And we could save several different tables with different position pointers if we needed to. So that's one example of where we could use this end colon statement to make sure that we clean up after ourselves and get our file pointers back. So the combination of that and the save and restore positions is pretty handy.
Well, I got one question.
I'm going to show you a result in just a second, Chris.
How the heck did you ever find end colon?
Because I was searching for something entirely unrelated and found it.
And then you said, wow, that's cool.
Yeah. And I've got this cool little program called Evernote where I throw cool shit that I find in. And one day I go back around and actually play with it.
I got you.
Okay,
I just wondered because I said, hey, man,
it's the craziest thing in the world, but it's definitely a handy little command.
So the end colon is basically your exit routine. It's your do exit.
Exactly. Yeah, in our Clarion world, it's do exit. That we always had to make sure we called.
Yeah.
It works very similar to the exception, on error exception. If we put a block of code in that on error, it fires anytime there's an error. Well, this code with the end colon fires absolutely every time you exit. We'll just step through that one more time so you can see. Before we call, we're on record 11. We get in there, we're still on record 11. Then when we do our read, we're obviously on 5. And then when that return issued, it did a restoring position and reset our position back to 11.
And the hello doesn't show up because it doesn't do anything after the return.
Yeah, exactly. And we can actually, let's look at this another way. Let's go through it with the debugger. It's amazing how well I've done at getting my logo on these webinars, isn't it?
You're awesome, dude.
Okay, so now we're in the debugger. And we can step out of my fancy-dancy trace statement there. All right. Now we're going to read the record. We're going to issue another trace. Now we hit the return statement. And you see when the return issued, it immediately jumped down to the end colon.
That is,
and did the HRestore.
So what if you have no return?
Well, if you have no return, it'll fall through all the code. And I believe the end code will be executed, but that is a good question, Arnold. Let's see that.
I think basically the encode, if you got that in there, I think the encode gets executed no matter what.
Right, I believe it would.
Because that's just a tag, right? Kind of.
Yeah. It's a very smart go-to.
No, don't say go-to. Never say
go-to. Back to basics.
I knew Arnold would understand what a go-to was.
That's right.
He got them all over in his code.
He's a go-to kind of guy.
Hey, we got an info message up somewhere. There it is. Oh, well, that's misfortunate, isn't it?
Oh, no. Maybe you should just do a little trace.
I think when I flipped over, I somehow, I think when I flipped over, I managed to get it confused. Let me do this so that we don't have to step over these trace statements. You want to tell them what I'm doing with that WL, Andy?
WL is basically the trace statement. He's overloading it. By doing this with the WL, he's calling the WINDEV language version of it instead. So he can skip right by his code where he's running the trace and run the actual trace code from WINDEV.
Yes. All right. So as you see, Arnold, it still executed your end code.
Yeah.
It just fell through.
Yeah, but did it skip hello there?
No, because there's nothing to tell it to skip it now.
Yeah. Oh no, I was just following the arrow and it just jumped down there. But what you're saying, it's in the trace.
Right.
Yeah.
All right. So that's one simple example. Now, a more real-world example that I tend to run into a lot is processing of import files. So let's take a look at some sample code for that. You know, we're setting up, reading our file, processing through it. Well, my users tend to give me bad files more than they give me good files. So I always have all this error checking code in place. And back in the old days, before I found the end statement, I would have to put this error message into a string and then test for, is there a value in the string? You know, then I would do a break here. So I would say, you know, error message equals that, and then I'd do a break, and then down here I'd say if error message doesn't equal quote quote, then got an error, you know, and I'd have to make sure to also do my close file here, and then I'd also have to do my close file down here. And you see, I mean, we're not talking a lot of code, but you know, as we've discussed before, every line of code is one more opportunity to introduce a bug. So instead, we can get rid of all that code.
Don't you still want the break there?
Nope, because the result's going to throw me completely out of this procedure.
Oh, it's like dropping to the bottom. Okay.
Well, no, it's not. It's not like dropping to the bottom. Result is
get you out.
return. I mean, you know, it's sending it back. without the end colon, that would jump straight out, and I would have left this ASCII file open.
Mm.
Which causes a memory leak.
So, well, causes a memory leak and causes ticked off users when they try to open that file in Excel or something.
Well, damn.
Yeah, and yeah, I'm more concerned about the memory leak myself.
That's
you know,
me.
my users are ticked off for one reason or another all the time. So, must be that stellar support I offer.
A lot of users too, huh?
Okay, so
Success.
we jumped through here and we got a success. And if we look at our trace, we read our 2 lines, and then we said going to close the file, so our close file code executed. Okay, now if we go back and look at the code, that's a normal, we read each one. I guess I ought to put a header row here so that we actually get all 3 lines.
Hey, do you leave your trace statements in, or do you just comment them out later?
That's the reason we overload the trace.
We've got a deal in there where trace is run out of a routine, and we look at in test mode, and we can literally turn on the trace based upon a global variable of whether or not we actually trace or not. And you set that trace up in your default manager, and in doing so, you can be on the customer's machine, turn on the trace, see what they're doing, then turn it back off.
Cool.
So that's the reason why we do that.
You turn it on in with the command line?
Well,
in the command line?
You can turn it on.
Command line, registry.
Yeah, registry.
Or a parameter. Oh, okay. In the program, you can turn that global on.
And the second part about this is that you can turn on that trace. That gives you the other trace, and then I've already set up, and we might go over that next Friday because it's a 15-20 minute deal. Well, actually, not next Friday. I can't do it next Friday. I'll be actually riding Harleys. But what it does is actually traps all the keystrokes. It traps the keystrokes, and you can bring that into your test program as part of your test stuff. So I'll put something together, and we'll run through that. Okay.
Cool.
Yeah, and you see in this particular version I'm showing you here, I've got 2 different settings for debug. If debug is 0, trace doesn't do anything at all. So now my trace statements can stay in my program, but all I got to do is set debug to 0, they go away. If I set it to 1, all I'm doing is calling the W language trace, but notice I'm sticking the current win in front of whatever the message is. So now I can see what window that trace statement was generated from. And then what I use a lot at my client sites is they'll be having some kind of weird problem that's random, meaning whenever she forgets how to use the program properly. So I will set debug to 2, and what that does is instead of tracing to the screen, I capture that into a table I've got called syslog and write those messages into syslog into the database. Then when she calls and says, it did it again, I can go into the syslog and see exactly all the trace statements and hopefully figure out what the heck she's doing that's causing her problem.
So the message text or the error description is your message, right? It's not a system message.
Yeah, it's whatever's in your trace statement.
Yeah.
Yeah. Now, in my real world example, I capture the file error messages and a bunch of other stuff as well. But this is my generic open source example.
Is there a thing called like equals current proc? Like so I know what
that's what current win is.
But that's just, oh, that's the window though, right?
Remember, the window is your procedure for the most part, other than your global procedures.
I guess so. Yeah. Okay.
Your window is your procedure. All right, so back to our import example here. As you see, there's 3 different places where I'm testing, and if they put in an invalid value, I'm returning an error message and jumping straight out. And if I go over here to my other monitor and make the file invalid, we will see that code fire. See, we got an invalid or inactive branch on line 3. Okay? If we come over here, we see that we still closed the file. And the reason why is, once again, our magic little end colon statement. Oh, wrong program. When this result fired, our end colon down here still fired off and closed our file.
I like that, man.
Yeah, it's, you know, that's the thing with WINDEV WebDev, is it's subtle little things like this that, you know, by themselves aren't a big deal, but the more of these little things you learn and start using, the cleaner and more stable your code gets. As I said, I mean, in a routine like this, and the actual routine I copied this from is probably 200 lines of code processing that file, because there's all types of error checking. And as that code goes on and on, it gets more and more complicated to make sure that you're capturing the error and you're cleaning up after yourself and you're not skipping out of something. And, you know, again, every line of code is an opportunity for a bug. By using the end colon, it cleans up that logic, and there's no, I kind of equate it to, you know, it's kind of like a trigger in a SQL database. You know, that's why I love triggers. They're going to happen. I don't have to worry about, well, when I update the customer social security number, I have to do this. Well, guess what? A trigger keeps me from ever having to worry about that. I know it's always going to happen. Same thing with this end colon. I know whatever code I put in that end colon will execute when this procedure ends.
Kind of like the construct and the destruct type of thing. It's going to happen.
It actually is a destruct of a class, is the exact same thing.
Mm-hmm. Sweet.
So that's Uncle Pete for this morning. Like I said, nice, quick, sweet, short one.
Okay. So if there's no questions,
Chris is typing something over. Okay. So I answered your result question then, I assume. All right. That's it, okay. Unless there's any other questions.
Okay. I'm going to stop the recording and start it again for Glenn. Stand by. Thank you, Pete.